Okay, let's continue talking about vertex of a parabola. So we've talked about vertex of the parabola would be that center of the parabola, which is either the maximum or the minimum, depending on which direction your parabola is facing. So let's talk about this guy. Let's talk about how to find it when it's not written in an easy form. So I've got a function f of x equals x squared plus 6x plus 4. And what you want, let's write down what it is that we want. What it's asking for is to find the vertex. So we want something that looks like f of x is equal to a times x minus h squared plus k. Okay. This is that standard form of a parabola. This is the form that's going to give us what we wanted, the vertex, which would be written as h comma k. So this is what we want to find. In order to do that, notice what we have is we've got this x minus h squared. So that is a binomial squared. In order to get that binomial squared, we're going to need something to factor as a perfect square, which is, of course, called completing the square. So let's go ahead and try to complete the square. So I'm going to rewrite the problem that we've got here. We have got f of x equals x squared plus 6x plus 4. Let me make sure that's the same one. Okay. Alright, so this is what we're going to try to complete the square of. So first thing I'm going to do, I'll come back to that f of x part later. I'm going to deal with this x squared plus 6x. I'm going to leave the plus 4 kind of on the side. We'll get back to that. We'll come back to that later on and deal with it. That constant you're going to come back to. What we need to deal with is the variables, the x. So the steps that you follow when you complete the square is, first of all, you take the middle number and you divide it by 2. So that middle number, that's coefficient in front of the x. You divide that by 2, and what I've got is I've got 3. And then you're going to take that number and you're going to square it. That's what you are going to add so that something will cancel. I'm sorry, something will factor perfectly. So 3 squared is 9. So that's what's going to go here. But you can't just add 9 for fun. Okay? And also what I've also told you is that we're dealing with the f of x later. So I'm not even going to do anything on that side of the equal sign. So if I add 9, I have to also subtract 9. Okay, otherwise it's no longer the same equation. So if you add 9, you have to also subtract 9. Or like what we were doing before when we were solving these, we added 9 to both sides of the equal sign. But in this case, again, I'm not dealing with that equal sign quite yet. So let's rewrite that, what I've got. So now I've got x squared plus 6x, okay, plus 9. Actually, I'm not even going to rewrite that. Let me just highlight what we've got here. The x squared plus 6x plus 9, this is actually going to now factor. Okay, this is now a perfect square trinomial. This will factor into the x plus 3 times x plus 3, which is x plus 3 squared. Alright, so that's what that factors into. But then what we can also talk about next is what happens with this 4 and negative 9. That's just going to be those constants that I told you we would get back to you. So positive 4 and negative 9 gives you the negative 5. Okay, so this is now what I've got, which now I can deal with my equal sign and I'll still keep this calling f of x. Okay, what I've done is I have completed the square. I've written this as a perfect square trinomial factored, and then the constants sort of on the outside of those parentheses. So let's go back and look at what our standard form of the parabola was supposed to be. Okay. Again, we knew what we wanted was something like this. Okay. And what we got is something that looks very similar. We got f of x equals, and we got x plus 3 squared minus 5. So x plus 3 squared minus 5. And remember, the question was to find the vertex. Okay. And if you remember from what it is that we want, the vertex is the h comma k. So in x comma y, right? So inside the parenthesis changes signs, outside the parenthesis stays the same. So that is my x comma y. That's the ordered pair. That is my vertex. So I could graph that, and that would give me that center of the parabola, and we can continue to graph in more detail from that. But what I want to talk about is this going to be a maximum, or is this going to be a minimum? Okay. All right, so look at the function that we have. Okay. Am I doing any transformation outside the parentheses out front? Am I multiplying the y values by 2? Am I doing a vertical shift or a stretch? or a reflection. Okay. Remember, if you had a reflection about the x-axis, that would flip it upside down and make it an upside down parabola. But this is in fact a positive outside that parenthesis, so there is no reflection. Remember, a reflection was when we had that negative on the outside. So there was no reflection at all, which means my parabola at the end of the day is going to be an upside up parabola, okay, which of course means it's going to be a minimum. Okay, if it were an upside down parabola, it would be a maximum. All right, so that's the idea of how to find the vertex of a parabola algebraically. Okay, now we can certainly talk about graphing that. So -3, -5 was our vertex. Let's go ahead and graph that. Let's see what that looks like. Alright, so let's go ahead and graph that. Let me get my colors here. Alright, so my vertex was -3, -5. So -3, 1, 2, 3, 4, down here to -5. Okay, so that right there is going to be my vertex. And then another thing that we talked about is this is certainly an upside up parabola. So this is definitely going to be facing upside up. Oops, sorry about that. Here we go. Alright, so my parabola will look something like this, with my vertex being the -3, -5. Okay, and we'll talk about more detail and make that more of a perfect graph, but this gives us the general picture. Okay, another thing that we can find is the domain and range. That's other things that we've always found. The domain of every quadratic function is -infinity to infinity. The range, of course, you can look at this. This was an upside up parabola. So it's starting at the y value of -5. That's the vertex. And it's going up forever. So that's the infinite part of the range. Okay. Alright, so this is a general idea. Again, we're going to go into more detail and make that graph more perfect. But we at least get a starting point and then a domain and range. That starting point is the vertex, which in this case we've already discovered is definitely the minimum.